Hello, everyone. We're now going to listen to our lecture on we're going to begin our unit number 3, which is called Equations and Reactions. And we're going to start that by looking at translating. And you'll see what that means in just a sec. Okay, so let's think a little bit about what goes on when a chemical reaction occurs. There are some things or some clues that we can look for to tell us that a reaction is happening. For example, you may see a color change. Or maybe a solid forms from two liquid solutions mixed together. These things would indicate a chemical reaction is happening. Possibly bubbles will form, like when you drop an Alka-Seltzer tablet in water, or when we dropped that bit of sodium metal in the beaker full of water. It was very clear that a reaction was happening. And in that case, actually, there were some bubbles, but also some gas was given off, and we actually saw flames. Um, and in that mode, another possibility for knowing when a chemical reaction is occurring is that heat can be produced, or heat can be absorbed. So you can mix two solutions together, for example, and the beaker that they are in will get cold. That's absorbing heat, and you'll know that a chemical reaction is going on. All right. So these are the clues that can tip us off to the fact that a chemical reaction is occurring. How can we explain what happens in chemical reactions? Well, the way chemists do that is to write chemical equations. You've seen these before. You're probably a little bit familiar with them. We're going to spend this entire unit explaining how we create chemical equations, how we use chemical equations, and what good they are. All right, so a chemical equation's basic setup is that there are reactants. This is your starting point or the starting materials, and those reactants react with one another. That's what the arrow tells us. The reactants are turning into products or your end point. So you have a starting point and an ending point. You have reactants and products. All right, and we separate them with this arrow to tell us which direction things go. Now, later on, we're going to see that sometimes this arrow can actually be double-headed arrow, and the reaction can go both ways. But to start out with, we're going to stick with just a monodirectional kind of reaction where reactants turn into products. All right, now, we just did the unit on naming, and that's going to be a very important skill for moving into the next section. You need to know how to name compounds, how to write formulas when you're trying to create or understand chemical equations. All right, so what components go into a chemical equation? Well, we already said reactants and products, so you have to know who the players are. But we also need to know the physical states of the compounds involved. What do I mean by physical states? Well, these are characteristics like a solid or a gas or a liquid. All right, these are all physical states of matter that you're probably familiar with, and those are relevant in a chemical reaction. We're going to see why. And then there's also another state called aqueous. This word right here is aqueous. We abbreviate it AQ, just like we abbreviate these other ones, like these. Aqueous means dissolved in water. All right, so you can say a compound is an aqueous solution if it's dissolved in water. All right, and we'll see examples of that in just a bit. All right, so not only do we have reactants and products in our equation, we also have the physical states. Okay, so here's a starting point. This is a sentence that describes a chemical reaction, and our goal is to turn this sentence into a chemical equation. Let's look at this sentence. Solid magnesium metal reacts with hydrochloric acid to produce hydrogen gas and aqueous magnesium chloride. All right, so what we want to do is turn that sentence into a chemical equation. The first thing that we're going to want to figure out is who are the players, what are the reactants and the products, and what are their physical states. Okay, let's think about reactants first. Well, the sentence tells us that solid magnesium reacts. That's a clue that solid magnesium is at least one of the reactants. Oops, jumped ahead too quickly. Reacts with hydrochloric acid. All right, so solid magnesium is one of the reactants. Hydrochloric acid is another of the reactants because it's of this verb here. And we've shown the abbreviations, or the chemical formulas here. We'll start with hydrochloric acid because we're a little more familiar with that one. Hydrochloric acid is HCl. We know that because we just spent time learning how to name acids. Hydrochloric acid, the formula is HCl. It does not tell you, that the acid is aqueous, but from one of the definitions from our earlier lecture on naming acids, I told you that acids were always dissolved in water, which means aqueous. So when you see something like hydrochloric acid or hydrobromic acid or nitric acid or something, you can assume it is aqueous. It is dissolved in water. So that's going to be the state of matter for acids. Now I kind of skipped over solid magnesium metal. How did you know that solid magnesium metal was just Mg? Well, because a metal, this tells you when it tells you that it's a metal, it tells you that means there isn't any other element around. If there were another element around, it would have to have another word in the name. So since this just says magnesium metal, that just means it's Mg. And it's solid. Almost all metals are solid. So we maybe could have assumed that, but the sentence actually tells us that it's solid magnesium metal, so we abbreviated Mg, and we have the parenthesis with an S to indicate solid, and here we have HCl with a parenthesis around the AQ to indicate aqueous. Okay, so there are our reactants. We can see the word to produce here, or rather the phrase to produce here. That gives us our arrow that goes from reactants to products. So now let's find our products. Well, hydrogen gas is one product, and we haven't touched on this much yet, but hydrogen is one of the 7 elements that that can't be all by itself. There are 7 of them that must be diatomic. In other words, they're not allowed to be just an element, a single atom all by itself. There are 7 of them, and hydrogen is one of them. So since it tells us hydrogen gas, we have to assume that hydrogen is in the form of H2. Okay, that's the form for hydrogen gas. There are actually 7 elements that fall into this category. We'll go into what those are later. Actually, and then the G stands for gas, so we have H2 gas. So one product is hydrogen gas, the other product is aqueous magnesium chloride. Well, here they tell us right up front, this is aqueous, so we know that the state has to be AQ. And magnesium chloride, we should know from the last unit that magnesium chloride is going to be MgCl2, because magnesium makes a +2 ion, chlorine makes a -1 ion. When they two combine to make a compound, it must be MgCl2. That's the formula. All right, so you see how that step worked? So you have to kind of parse all the words in the sentence to find the reactants, the arrow, and the products, and you write the formulas for each of the reactants and products. All right, so I've summarized that information in a table because this is a kind of a handy way, at least to learn to do it. I don't know that you would actually write out a table like this on a regular basis when you're working a problem, but it's handy to think about this as a tool when we're learning. Here are the reactants, here is the arrow step, and here are the products: magnesium, HCl, hydrogen gas, magnesium chloride. So now we're going to rewrite this information we have in the table as an equation. And we do that by writing each of the reactants with its state, magnesium solid, and a plus sign, and the next reactant with its state. And in this case, we only have 2 reactants, so we stop there. We might have had multiple in a different example. Here, only 2. We bring the arrow down to produce. We write our products, H2, gas, and a plus sign, and magnesium chloride in the aqueous phase, AQ. All right, so that's how this table converts into a chemical equation. So this is an example of a chemical equation. So let me summarize the steps for translating a sentence into a chemical equation. First, we identify the reactants and the products by parsing through the sentence very carefully to figure out what is a reactant, what is a product, find the verb that tells you to produce or to create, and that will give you your arrow. You have to write out the correct formulas for each of the reactants and products, and I don't mention it here, but you also have to include the state, so solid, liquid, gas, or aqueous, and then you write an equation like we just did. I should point out that the equation that we wrote is an unbalanced equation, and you might wonder what unbalanced means. Well, we're going to pick that up tomorrow in the next lecture. That's it for now.